Welcome back, everyone. Just before the break, we defined common difference. Now I'm going to take that definition and the fact that it's a property of a linear pattern, and we're going to first look at an example before defining what a quadratic pattern is. So first, let's have a look at our linear pattern example. Will you please follow on the board with me? So the question says, determine the common difference and the general term for the following sequence. So I'm going to go to the next slide so we can see it a bit more clearly. We can see that we've got term 1, term 2, term 3, term 4. And if I am first trying to look for my common difference, let's have a look. We're going to look at our terms going from term 1 to term 2, term 2 to term 3, and term 3 to term 4. From term 1, which has a value of 10, going to term 2, which has a value of 6, we can see that we subtracted 4. Then going from term 2 to term 3, I again subtracted 4. Then going from 2 to negative 2, I again see that I subtracted negative 4. So great. We have established that this is a linear sequence. Why is it a linear sequence? It is because it has a constant common difference. We can see that between each of these terms, to get from term 1 to term 2, from term 2 to term 3, going on, I had to subtract 4. So D is equal to negative 4. Please be careful and don't say positive 4, because remember, we are subtracting 4. We're not adding 4. The next step is to find a general term for our sequence. So we need to see if there's a relationship between Tn and n so we can have a general term for the sequence. Please turn your eyes to the board with me again as we find it. So we've already discussed that between each of the terms, we subtracted 4. Now, I'm going to see if we can find a way to write this as a rule. So we had term 1 is equal to 10. Then term 2 was equal to 10 minus 4. So essentially, this was 10 with one common difference. I'm just writing CD because I don't have enough space on the board. But please remember, I'm adding a common difference, but I know that this has a negative value. Then for term 3, we can say that I had 10 minus 4 because that's the value of term 2. But I then subtracted another 4. So that means I had 10 plus 2 common differences, and 2 common differences in this case, I'm just going to write it in red for us, would be negative 8. Then if I write an expression for term 4, we can see that it was 10 minus 4 minus 4, which is the same as term 3, but I'm going to subtract another 4, which is going to lead to this negative 2 value over here. So this would be 10 plus 3 common differences. Also, just before I conclude about this, I'm sure everyone will agree that the first term over here was just 10. There were no common differences added over here. So I'm hoping that everyone can see the pattern that for term 1, I had no common differences. For term 2, I had 1 common difference. Term 3, I had 2 common differences. So each single time, the term value, let's write it as Tn, because we know that that's representative of the term value, was equal to 10 plus n minus 1 times negative 4. What this means is that the value of each term was found by taking 10, which is the value of my first term, and adding 1 less than the term value times negative 4, which is my common difference. So if I want to simplify this, I'm going to have 10 minus 4n plus 4. So it's going to be equal to 14 minus 4n. Great. So hopefully everyone's with me so far. Just another important indication that we always need to see the relationship between the term value and the common difference as well as the term number. Let's have a look at our next definition. So we are now going to be looking at something called a quadratic pattern. I've already discussed linear patterns, but now we are going to be talking about quadratic patterns. A quadratic pattern is a pattern where the second difference is equal. So now you're probably going to be thinking to yourself, what is the first difference and what is the second difference? And what's the difference and why do I need to know the difference? I want you to please write this down for me. A linear pattern has first differences equal. A quadratic pattern has second differences equal. We're going to look at an example and I'm going to clearly indicate to you what is a first difference and what is a second difference. Let's have a look at the board. So we are being given an example that's asking us to consider the following pattern that goes 1, 2, 4, 7, 11. And we are going to determine whether it is a quadratic pattern. Just a reminder, a linear pattern, I'm going to say this a few times, everyone, just to make sure everyone understands. The first differences are equal. A quadratic pattern, we have the second differences equal. So I've put the pattern behind me. We're first going to calculate the first differences of the pattern, and then we're going to calculate what we refer to as a second difference. Let's have a look at the first differences. So a first difference is essentially the values between the terms of the pattern. So first difference between 1 and 2 is positive 1, because I can see that I added 1 from 1 to get to 2. Then to get from 2 to 4, I added 2. Then to get from 4 to 7, I added 3. To get from 7 to 11, I added 4. The numbers that I've written on the board, these are first differences. So, first differences are the differences between the presented values in your pattern. So if I give you a pattern and you figure out the differences between those term values, that is your first difference. If your first differences are equal, it is a linear pattern. Now, everyone at home, I'm going to ask you, is the pattern behind me linear? Yes, no, maybe. Are my first differences equal? No, I'm hoping there's some shaking of heads at home. The first differences are not equal. But we're now going to check if it is a quadratic pattern. A quadratic pattern checks whether the differences between the first differences are equal. That may sound a bit like gibberish, but all I'm saying is I want to see what is the difference between the values of my first differences. So let's have a look at them together. If I'm looking at the difference between 1 and 2, I can see that there is a difference of positive 1. If I'm looking between 2 and 3, I can see that there is a difference of positive 1. If I'm looking between 3 and 4, I can see that there is a difference of positive 1. So the differences between the terms of the first differences is called the second difference. So I'm just going to repeat myself just to make sure we're all on the same page, because there is a lot of use of the word difference. If I give you a pattern and you calculate the difference between each of those terms, that is called the first difference. If the first differences are equal, then it is called a linear sequence. If the second differences are equal, and what is the second difference again? I'm hoping you're thinking of a definition. The second difference is the differences between the first differences. If the second differences are equal to each other, then it is a quadratic pattern. So behind me, I calculated that the second differences have values of 1. Because all of my second differences are equal, do you think I can conclude that it's a quadratic pattern? I'm hoping that you're saying yes. So let's write it behind us. The example behind me is a quadratic pattern because the second differences are equal. So let's conclude on the board. So, as the second differences are equal, it is a quadratic pattern. Okay, so I'm going to ask a hypothetical question. If I gave you the pattern 5, 10, 15, 20, 25, 30, is that a quadratic pattern? I'm hoping that you're going to be saying no, because that has a common difference or a common first difference of 5. So that means it is not a quadratic pattern. So what I'm going to do with you now is I'm going to look at the concept map with you, just to make sure you're happy with what I've covered so far. So we discussed that we have a common difference or a common first difference. That's when we discussed that the difference is equal to Tn minus Tn minus 1. And if that difference is common, it is a linear pattern. So that's when it's like that example that I just said, which is 5, 10, 15, 20, going on. We can calculate a second difference by taking the differences of the first differences. And if it is a common second difference, it is a quadratic pattern. In the next lesson, I'm going to be defining the general term for a quadratic pattern, and we're going to see what calculations we can make using the nth term. Great, so now we've defined first differences, second differences, and after the ad break, we're going to look at some more practical examples of quadratic patterns. See you just now.